Now we can slowly prepare the next presentation, which will be given by Hamza Beddaa. He is working on the PhD thesis, which is effects on the incorporation of dredged river sediments on the physical, chemical, mechanical, and durability properties of concretes. And he is from the University Paris East University. And he will talk about drying, shrinkage, and mechanical properties of concrete based on Corbicula shells from river sediments as coarse aggregates. So I'm looking forward to your presentation because using of some natural materials also as some sort of aggregates in the concrete is a very hot topic. So maybe your approach will be for the future very important and interesting. So you can introduce yourself in the beginning, and now you have 15 minutes for presentation of your work.
Hello everyone. My name is Hamza Beddaa, PhD student in the Ecomaterials Laboratory of CERN de France. My thesis is entitled The Effects of the Incorporation of Dredged River Sediments on the Physical, Chemical, Mechanical, and Durability Properties of Concrete. The thesis is made under the direction of Jean-Michel Toroti from Gustave Eiffel University and provided by Amor Benfrage and Francis Lavenne from CERN. So I'm going to present today one of our research results, which deals with the effect of the substitution of coarse aggregate by shells from river sediment on the drying, shrinkage, and the mechanical properties of concrete. So the sediment studied in this disease are the sediment generated by dredging operations carried out in the Île-de-France waterways. These dredging operations, which are essential to ensure the transport of boats, generate an annual volume of about 150,000 cubic meters. So these materials are considered as waste, while the analysis show that 100% of these materials are non-hazardous and 90% are inert. And the sand fraction of these materials represents 50% of the total volume. So all these informations favor the valorization of these materials in concrete as aggregates. However, this new local resource of aggregates may contain a significant fraction of shells, which can have an impact on the concrete properties. So the shellfish species present in the waterways of the Île-de-France region are Viviparus, Dreissena, Corbicula. Viviparus and Dreissena are light and can be easily removed by blowing or floating, whereas Corbicula are dense and it is difficult to separate them from the sediment by a practical way. So the incorporation of sediments into concrete means the presence of this type of shells in the mixture, and then the study of their effects on concrete properties is important. So these shells are from 4 to 20 millimeters, the same granular class as coarse aggregate. So we will study the effect of the substitution of coarse aggregate by shells on the concrete properties. So comparing the properties of the shells with those of the coarse aggregate, we can say that that shells contain less thin elements. And comparing the properties, we can say also that the density is less for the shells, and they absorb more water than coarse aggregate. Concerning the flakiness index of shells, it reaches the maximum, which is 100%. So this flattened shape of the shells requires more past volume to cover them, which could affect significantly the concrete properties. So the control concrete in this study is a concrete of C30 class with a good workability as far as slump class, using a water to cement ratio of 0.55. This study is carried out on 7 concretes, one control concrete and 6 concretes based on shells. The volume substitution rates used in this study are 2.5, 5, 7.5, 10, 20, and 100%. The properties studied for this study or for this concretes are slump, porosity, drying shrinkage, and weight loss. Regarding mechanical properties, compressive strength, elastic modulus, and tensile strength by splicing are also measured. So we will start with the result of the physical properties. The slump of the fresh concrete was measured using the Abraham's cone, and the results show that up to 20% of substitution, the slump of the concrete based on shells are similar to that of control 1. However, a significant decrease of the slump was measured for a total substitution of coarse aggregate by the shells. So the decrease could be attributed to the important past demand of shells due to their high specific surface area. So concerning the porosity accessible to water, the results show that the porosity remains unchanged for the substitutions lower than 20%, but for a total substitution, we can say a significant increase in the porosity. This result can be explained by the fact that up to 20% of substitution, the air trapped by the shells is negligible compared to the porosity of the overall concrete, while the total substitution of the coarse aggregate by shells makes this effect and this porosity much more pronounced. So the shrinkage test is carried out on prismatic samples of 728 centimeters. Show that replacing up to 20% of coarse aggregates by shells doesn't affect the concrete drying shrinkage evolution. And the weight loss over the 3 months has been also measured on the same prismatic samples, and the result of this parameter is coherent with those of the shrinkage. So there is no effect up to 20% of substitution. This finding can be attributed to the use of the same water to cement ratio and the same mortar volume fraction for all concretes. For mechanical properties, we start with the compressive strength. The compressive strength was measured on cylindrical samples, and the test was carried out at 28 and 90 days. So for the result, the compressive strength decreases as the replacement rate increases. This decrease is significant, and it is about 21% for a substitution rate of 20% and reaches 62% for a total substitution. So the effect of shells on the compressive strength of concrete has been the subject of several studies, and the decrease of this property has been attributed to the fragility of shells, which don't seem the case of our study of our shells used in this study, or it was attributed to the increase of the concrete porosity, and this explanation also may be the case for the total substitution, but up to 20% of substitution, the effect on the porosity of concrete is negligible, while the compressive strength decreases significantly. But the possible explanation for this decrease seems to be the weak bond between the shells and the mortar. No, actually, the observations of the bond between the inclusions and the mortar in a concrete sample show a difference between the adhesion quality of coarse aggregate and that of shells. So an absolute lack of adhesion here and here, or even detachment could be observed between the mortar and the shell, especially on the outer face, of the shell. For the inner face, a high porosity could be observed because of the shape of shells, which favors the air trapping. So the lack of adhesion between the mortar and shells could be the main reason of the decrease of the compressive strength. So the elastic modulus was measured on the same samples dedicated to the compressive strength. The elastic modulus values follow the same trend as the compressive strength. The only explanation for this decrease is also the weak adhesion between the shells and the mortar. The tensile strength by splitting was measured on the cylindrical samples. The error bar of the obtained result is significant, but the averages of this result show a clear trend regarding the effects of the shells on this property. So the tensile strength decreases significantly with the increase of the replacement rate. In fact, this property reflects the adhesion quality between the aggregate and the mortar, and its decrease confirms the weak adhesion between shells and mortar. So I add to this presentation a sample theoretical part in order to show that if we consider a lack of adhesion between the shells and the mortar, the Mauritanic scheme can provide equivalent values to those found experimentally. So first, the elastic modulus of the different phases are measured. The elastic modulus of the mortar is measured in the same way as concrete, as the concrete, while the elastic modulus of the inclusions are obtained from the micro indentation test. The Poisson's test, the Poisson's ratio is considered equal to 0.2 for all phases. So assuming that the inclusions have a spherical shape, either coarse aggregate or shell, the homogeneous modulus of the concrete can be calculated using the Mauritanic scheme for the different substitution rates. The figure shows three elastic modulus values for each replacement rate. One corresponds to the experimental value, and the two others correspond to the theoretical values. The bars in red correspond to the case of a perfect addition between the shells and the mortar, while the bars in blue correspond to the case of a detachment between the shells and the mortar. So this case of detachment could be described mechanically by a pore instead of the shell, which means that a modulus equal to 0 is assigned to shells. So the results show that if we assume a perfect addition between the shells and the mortar, the elastic modulus decreases by only 2% for a substitution rate of 20%, while the assumption of a detachment between the mortar and the shells gives elastic modulus values close to those measured experimentally. So it can be concluded that a decrease in elastic modulus with the incorporation of shells can't be attributed to the low modulus of shells, but rather to the weak addition between the shells and the mortar. So to conclude, this study focuses on the effect of shells of Corbicula type, which are omnipresent in the sediments of Île-de-France region. So the substitution of 20% by volume of coarse aggregates by shells shows no effect on showed no effects on slab porosity, shrinkage, and weight loss. However, a total substitution makes the effects of the shape and the high past demand of shells more pronounced by decreasing slump and increasing porosity. In contrast, mechanical properties decrease for all substitution rates. This decrease has been attributed to the weak addition between the mortar and the shells. This is the end of my presentation, and thank you for your attention.
So thank you very much for a very interesting presentation. And now we will start with questions. So maybe I will start with one. In fact, you mentioned that you are using the shells which are in full size, we can say, but you also mentioned that because of the shape of the shells, so there is a more danger of the air bulbs inside the shells, and that there is a also problem then with remaining air bubbles. And so the question is, did you think or tested that these Corbicula shells can be maybe melted, crushed to small parts, and what will be the effect to the final mix and concrete?
So we didn't test this part, but we look to do that after. But I didn't have any result about using the shells as sand or as small parts.
Yeah.
But the effect of the interface, I think, is will be here if the shell is as we use it in this study, or as a sand.
Yeah. I understand. I also understand in your presentation you mentioned that there is a difficulty how to separate these shells from the sand. So it would be also a technological problem how to separate and then crush it. Yeah. So I understand, but still it's interesting maybe way for the future research how to make it, maybe how to improve the quality of the concrete. Okay, so now I would like to ask also other chairmen to ask. So who would like to start, Oliver or Vladislav?
Yes, thank you, Peter.
Okay.
I can begin if you want, Vladimir.
Yeah.
I can begin. So I've got two questions. The first one is about the concrete. You propose a mixture of a concrete, but in which application? Is for what? Your mixture of concrete is for what application? In building or something else?
Yes, we look for using the sediments as a resource of aggregates. So there is some we will not use just shells in concrete, but the sediment that we will use contain the shells, and we must study the effects of shells on the concrete. So our objective is not to use just shells.
Yes, to use shells within concrete. Yes, I understand.
But the use
for which or for what application?
Yes, for the application is for the sediments. It's not for shells, only shells, but for sediments with including shells.
Okay.
Maybe I will ask you, because I understand the question. The question is, if you expect that, for example, it will be used for some structural applications as a load-bearing structure, for example, which is very sensitive about the quality. So there can be, for example, non-structural applications of concrete, some pavements, and so on, or structures. So I understood that the question is, what the way of application of this concrete? Is it right, Oliver?
Yeah, that's right.
The two possibility is here for pavement or for the constructor concrete for building or other. But the objective is the use of sediments, is not the use of shells only.
Yes, it's clear, but it is in the mix. So
in the mix. So the percentage of shells in the sediments is not very much So the objective is the effects could be acceptable if the percentage of the shells in the overall concrete is just 2.5% or 5%. But for pavement, I think it's good. It's a good use for this materials.
I think that really for pavement
or for porous concrete.
Yeah, it would be okay, but for structural concrete, so there the really the quality and the statistical value, so it would be maybe would take much more time to test it, to have it for the application in as a structural concrete. Yeah, so but okay.
Thank you, Peter. So I've just one little question now about the Young modulus of the shells. Do you really measure the Young's modulus of the shells or not?
We have tested the Young modulus with the micro indentation test.
Okay, and it's about what?
It's about the value.
Yeah.
Yes, I present this in this part.
24.
Yes, 24 and 31 for the aggregate, coarse aggregate used in this study.
Okay.
Okay.
Okay. Thank you.
Thank you. So Vladislav.
Yeah. I have the same questions as you about shell crushing. And I ask another my question. What is the volume weight of your hardened concrete? Is it suitable for light concrete, or it is normal concrete with shells?
Yes, it's a normal concrete. It's about 2.5. The density of our concrete is about 2.5.
It is very interesting. What is the volume weight of the shell in comparison with, of course, aggregate, for example?
Because the shells use the. I didn't hear the question.
The volume weight of the shells in comparison of the coarse aggregate. For example, when you use only shells. If shells have lower weight than the coarse aggregate, I think the volume weight of the concrete, hardened concrete, must decrease.
Yes, if we use the 100% of shells, we have a 2.4. So there is no a big difference because the density of the shells is also good. It's not the density is about 2.2 and the density of coarse aggregates is 2.5. So we if we use 100% of shells, we don't have an significant effect on the weight volume of the volume weight of the concrete.
But the quantity of shells in the 1 cubic meters is in the weight of quantity of shells in 1 cubic meter is the same that of course aggregate.
I didn't understand the question. It's about the fraction volume of shells. Yeah. Or about the difference between the density of shells.
I understand, but I understand with density, but the quantity, the volume of shells in 1 cubic meter is not the same that the volume of coarse aggregate.
No, the substitution is made with volume, is not with mass, because so the same volume. We change the same volume by the same volume of.
Okay, I understand. The same volume by
the same volume.
Okay, but you mentioned that one of the idea is that you can excavate the sand, including the shells from the river, and what will be what is typical fraction of the shells in this sand? Because if you would like to use it directly without separating, and you said that this is difficult to separate, and then to mix it, so you can do it in laboratory. It's okay, but if you would like to go to the application, to the practice, so probably the idea is to use what is excavated from the river. And what is the typical fraction of shells in this sand?
So it's differ from one digit point to another digit point, but I don't have any numbers of the fraction of this of shells in the overall sediment of Île-de-France region.
Okay. I just ask about some typical one. Yeah. So
I don't have an exact number of their percentage in the overall.
Yeah.
We can say 10% in one digit point and 0% in another digit point. So it's different.
Yeah. Okay. So there is a no. It is what about the durability properties of the concrete made with shells, especially freezing and thawing resistance. And thank you for sharing your amazing work. So it was given by or the question is by Cassiani Daniel. So please. What is the durability What is the durability properties of the concrete made with shells, especially freezing and thawing resistance?
So the quantities of durability tests in this for this concrete are carbonation and chloride diffusion. So for these two property, there is no effect up to 20% of substitution, but we didn't test 100% of substitution. But the other durability quantities or properties are not tested.
Okay. So the other question from Sadrin Mansour, a very interesting presentation. Were the shells washed before mixing in the concrete? Did you try cement paste with chemical mixtures or only without?
The question, I didn't understand.
Okay. So again, the question is, were the shells washed before mixing in the concrete? If you washed the shell?
Yes. It was washed and dried before used in the concrete.
And the second part is, did you try cement paste with chemical admixtures or only without?
Cement paste with using shells.
No. If there were some chemical admixtures in the cement paste.
No. There is no admixture. No.
Okay. And the last one is by Farid. Thank you for your presentation regarding cracking risk by shrinkage. There are several parameters to take in account as shrinkage, Young's modulus, tensile strength. Is it possible to say if incorporation of shells will decrease or increase risk of cracking by shrinkage?
So I didn't know.
Yeah, you didn't test. No. Okay, and the last question is by Jean-Michel Torrenti. In fact, in the Paris area where these sediments freeze thaw is not an issue. Yes. Okay, so this the problem of freeze and thaw is not the problem for this area. So this was just comment. Okay, so it's exactly 15:30. So thank you very much for your very interesting presentation.
Thank you.
And also thanks for the questions.